everyone. My name is Dee Zeiss, and I am the host of the monthly KubeChat webinar series. I want to welcome everyone to today's session, What Your Kubernetes Cost Reports Aren't Telling You. So moving on to the agenda here, we're going to be starting off with just some basic introductions to our speakers before we dive into the real content of everything. I did want to give you a couple housekeeping items today. So we'll be recording today's session. So if you can't stay for the whole thing, that is totally fine. We will send you a recording of this probably early next week. So be on the lookout for that. We'll send it to the email that you registered with. But we'll also put a copy on our website and our YouTube channel so you can easily find it in either of those places. In addition to that, on the console, you can see a PDF of the deck. So if you'd like to download a version of that, feel free and you can follow along. And then there's also a few links on your console for our next webinar that's happening in December, as well as an invitation to join our Slack community and also a link to install Kubecost if you're not currently using it yet. In addition to that, you'll see a little Q&A feature there on your console. So if you have any questions, feel free to submit those, and we will have about 10 minutes at the end for Q&A. So we'll cover as many questions as we can. We did get a number of pre-submitted questions too, so we'll cover a few of those as well. And that is all for the housekeeping. So moving on to our speakers here. So the first speaker we have is Joe. Joe is our Principal Product Marketing Manager here at Kubecost, and he has experience all across the board in industries like cybersecurity, cloud, fintech, edtech. He has a very deep background in product marketing, and he'll be helping you kind of understand some of the basics of how Kubernetes cost reports your cloud cost reports tend to hide those Kubernetes details that you really need to start making some better decisions for your company. And if you'd like to connect with Joe, you can see a copy or a link to his LinkedIn there. So feel free to go connect with him. And then our next speaker is Warwick, and he is an engineering manager here at Kubecost. He leads our platform and engineering efforts focused on secure, scalable backend systems. And he brings a deep experience leading global engineering and solution design teams across both regulated industries, but also fast-paced software environments. So if you'd like to connect with him, you can also find a link to his LinkedIn there as well. And with that, I will pass it over to Joe.
Thanks, Dee. Hi, everybody. Thanks for joining us. If you're not familiar with Kubecost, or maybe this is our first introduction, just a quick note about who we are. We were acquired by IBM about a year ago. We're a company that builds great software specifically for DevOps teams, platform engineering teams, for engineers to use. They use that to help them continuously understand and reduce their container or Kubernetes costs. Kubecost has both a cloud deployment, a SaaS deployment option, and a self-hosted option where you can control the deployment yourself and have it run inside of your network behind your firewall. It works on any Kubernetes environment, whether that's EKS, AKS, GKE, OpenShift, or rolling your own Kubernetes on-prem. It works across all of your clusters everywhere. We've got a lot of great customers that have entrusted us to help them manage their spend and reduce their spend. We're managing more than $5 billion on behalf of companies like Johnson & Johnson, Audi, GitLab, and a lot of other amazing customers. And we're a global organization, so wherever you are in the world, we're delighted to connect with you and see how we might be able to help. Now with that, let's jump into this. So we're going to start off with what cloud cost reports typically miss. And, no surprise, they miss a lot. They're pretty high level. Imagine sitting down to a group dinner with a big circle of friends, and you all have a wonderful meal. And at the end, they bring a single bill with a single total at the bottom and very little information showing how you got to that. If you've looked at your AWS cost and utilization report, if you've looked at your billing report from Azure, you might find a lot of similarities there with that group check that you might get. Not enough line item detail to understand who had the lobster tail versus who had the salad. And that leaves organizations with big visibility gaps. So most teams start with that big group meal bill, right? With the cloud providers bill where you have your containerized workloads running. And it tells you, like a bill, what you already spent, how much you owe, right? And it kind of breaks it down to those high level places, like you've spent X amount of dollars on EC2, on EBS, on load balancers, on S3, et cetera. But it doesn't really give you the level of detail that you need when you're running Kubernetes. Doesn't show you who, doesn't show you what, doesn't show you when those things actually drove incremental costs towards that big number at the bottom of the bill. Things like shared nodes, idle pods, over provisioned or over requested resources, they all show up looking like there's no problem. They are contributors to that bill, but they're not broken out in like a waste column or something like that. There's no visibility into the more granular Kubernetes metrics like namespaces or teams or labels or workloads. So it's really impossible to decipher at face value where your cost is coming from, what of it is waste, and what you might be able to do about it to optimize it from just those bills. And this isn't just an AWS or an Azure or a GCP problem. These blind spots exist across just about every environment, every managed Kubernetes cloud provider, and especially so if you've got on-prem Kubernetes or on-prem containerization that you're doing. Those are the most mysterious costs of all because there's just no telemetry or metrics out of the box that give you that data. So if you want to optimize Kubernetes costs, you're going to need a lot more than just like the monthly bill you get. You're going to need context. And to get that, you might need some specialized tools. You can go to the next one. So I mentioned a lot about waste, right? Waste doesn't just bubble up to the surface and say, hi, I'm waste, you should do something about me. You have to go kind of looking for it. And these are the kind of big three like cost blind spots that we find, that our customers find in their Kubernetes environments. First is in shared nodes, right? Your cloud bill might tell you how much you spent on compute for that node, but not who used that compute. It also is going to give you really high level attribution, not workload level attribution. So you don't get to know what jobs, right? What services were responsible for consuming that compute or consuming those resources. And this shared infrastructure, you know, when you look at it on a graph, is just a single bar. It's a single line. It doesn't get allocated to the various things that are contributing to its cost. It makes figuring out who owns those resources, who owns those costs, virtually impossible. Next place that Kubernetes spend really likes to hide out is in idle resources, things that you're paying for, but that aren't doing anything and are therefore providing no value. They are just a source of waste. When you request resources in Kubernetes and you use them either very efficiently, somewhat efficiently, or very inefficiently, or perhaps not even at all, you're still paying for those resources. Those things are still on the clock, costing you money every minute that they are up and running. So whatever is provisioned is getting assigned costs to it. If you don't need that, you're still paying for it. That's a gap that is really easy to go unnoticed. And for many of our customers is probably the single largest source of waste or opportunity to recover waste too. Finally, the last one is this kind of cross-team spend. So without doing things like labeling and tagging everything, nobody owns anything. Everybody owns all of it. And so it's hard to connect that spend back to specific teams, specific apps, projects, initiatives, business units, what have you. This kind of lack of visibility creates this no owner problem. And then cost optimization just has nobody to be a champion for it and run it forward. Warwick, over to you.
Thank you so much, Joe. What we're going to talk about quickly now is what to measure in K8s. Nothing too surprising from a technical perspective here. When it comes to understanding Kubernetes spend, the big four signals obviously are CPU, memory, storage, and network. Now, the CPU and memory drive node provisioning. If you over request, you're reserving and paying for capacity you may never use, and that idle utilization doesn't show up on your bill. For storage, the key issue is provision versus use. You get charged for the full volume size that you provision, not how much data is actually stored. If anybody who's got any Kubernetes experience knows, orphan PVCs are often a massive part of that hidden cost tax that sits with Kubernetes or with on your bill within Amazon, within Azure, and that sort of stuff. And it does become cumbersome over time. Now, the big one we find often now is with the network, and it's usually egress data. Data leaving a cluster, especially across zones on the internet or to the internet, add up quickly, as do idle load balancers, and they're easy to mischarge. That often just isn't visible in your standard bill. Tracking these four areas give the signals you need to connect usage with actual cost. Can I grab the next slide, please, D? Now, where this data lives is not surprising, but the difference between the two is really important. Obviously, the cloud cost reports give you the prices and total spend for node storage, load balance, and egress, plus some of the VM level metrics. Now, the K8s native data gives you pod and node usage, requests and limits, PVC sizes, load balance, and scaling events. Now, how that is experientially for users of the cloud, obviously, the cloud side knows what you paid, the Kubernetes side knows how it was used and by whom.
The trick now is knowing that difference. You've got to kind of do this three-step join up process, create a chain across these three items. So step one, you start with your cloud billing. You get what each node, what each volume, what each load balancer, what each egress line actually costs, and you measure that over a period of time to establish a bit of a baseline, right? Now that I know what those costs are individually during a particular time window, that might be a week, it might be a month, you're looking at this retroactively, so measure the amount of data that makes sense to measure, but don't drown in it. The next step is you're going to take Kubernetes usage data, right? You're going to take the metrics about utilization of Kubernetes resources, and you're going to want to split those costs across those pods and namespaces that ran on those resources. And all of a sudden, I've got alignment of Kubernetes costs and alignment of these like supporting cast of character cloud costs as well. The third is I roll all of that up using things like labels and namespaces so that I can start to see for the first time spend by team or spend by service or spend by app or spend by cluster or environment or wherever those labels and tags and structure that you've used to define your Kubernetes estate start to kind of surface individual buckets of cost that reflects real utilization that you can then attribute to a specific team or business dimension that makes sense. This is taking it from just this bill, you know, a slightly useful bill, and joining it up to usage, and by virtue of that, identifying owners of that usage and therefore the cost, the incremental cost that's a part of that bill that they're responsible for, right? And seeing and measuring are the first steps leading to accountability there. So once you have that chain kind of connected up, you can start making real decisions. You can start to have business impactful data to work from. Next section, we're going to talk about turning metrics, this data that we've just figured out how to generate, into some decisions, right? We need to take action for this to actually amount to anything is in terms of savings. So we're assuming that you've done those kind of three chain up maneuvers, that you've got cost mapped to usage, you've got that cost and usage mapped to owners, you now have this kind of trifecta visibility. This slide talks about what we do with it. The first lens that you're going to want to put this through is efficiency, right? Look at all of your requests, look at all of the utilization, and look at that by workload and by namespace, and see where you have either egregious mistakes or a trend towards underutilization or over provisioning, where maybe some right sizing activities wouldn't introduce a lot of risk, but could give you a lot of return on the time spent by saving you a lot of cost that is otherwise not giving you anything of value. Also, look for things that are terminally under provisioned. Those can also end up as a significant source of stress, but also cost as well. The second lens that you want to look through after looking at this from an efficiency standpoint is allocation and ownership, right? Nobody is going to care about the costs that they're generating until they realize that they own it, that it is theirs, that their actions were the things that led to that cost. So choose the namespaces, the apps, and the teams that are driving the bulk of your spend, and look at their utilization of shared costs, things like shared nodes and storage and network, and make sure that those things are allocated as well so you get the complete picture of ownership. So first lens is efficiency, second is allocation, the third is change, right? In the world of Kubernetes, everything is incredibly dynamic and everything can change moment to moment, much less minute to minute. So when costs are moving around, get your Sherlock Holmes hat and magnifying glass out and figure out what changed. Did we have a new deployment? Did we move infrastructure? Did we migrate some workloads? Were there some scaling events that happened? Did configs change? Was the drift correction from my GitOps solution making changes that we didn't know about? Find the cause for those spikes, find those causes for those dips, do more of what builds efficiency and do less of what creates waste is kind of the big takeaway. So the idea is like stop working with just data for the sake of working with data and leverage that data to help you start answering these three questions and really uncovering who owns the cost, how efficient are you, and what can you do about waste and where does it lie? And spotting waste, spotting risk is an absolute skill, right? In 2025, as we go into 2026, it's not good enough just to be Kubernetes savvy. It's not good enough to just write good code. You need to do it effectively and efficiently as well. So this slide really kind of talks about reading those same metrics that we're generating in two different ways. One, to identify things that you can safely scale back on to reduce cost, but also identifying those critical areas where making changes, doing this, maybe extreme right sizing potentially introduces breaking changes for your customer, right? Failures, servers that fall over, applications that slow down because you've attempted too much right sizing and you've not given yourself enough reserve capacity. So it is a balance. On the waste side, what you want to do is look for workloads that have requests that are just above and beyond sustained usage across a significant period of time. Make sure you include, the important days of the week, the important events of the year. Maybe Black Friday is coming up. Maybe you see a huge spike on Black Friday in terms of activity. You don't want to find yourself your app falling over on Black Friday because you cut a little too close to muscle on right sizing. On that waste side, right, you want to identify those areas where you're either over-provisioned, over-requesting, you've got resources like persistent volumes or load balancers that are just sitting there idle. They're not doing anything for you. Trim all of that fat. Do the good hygiene of like eating right and getting exercise when it comes to right-sizing those resources. Don't look at too small of a window. And the next is like on the risk side, watch out for things like CPU throttling because things are not provisioned correctly. Those out of memory events, autoscalers running and hitting their limits, even when things look efficient, you might not still have a healthy, stable, resilient, reliable infrastructure or environment. So the takeaway here, chase efficiency, but don't do it like in isolation. Don't do it with too little data. And always be realistic about balancing your savings against performance and reliability. This isn't really a min-maxing event. This is more of finding a good, steady state of balance. We can go to the next one. Some quick wins, low-hanging fruit, right? I think we've talked about doing a bunch of work already, right? Go mine up a bunch of data, take that data and start to look at it to understand utilization, and then net go take some actions. But all of this has to be done with some reward at the end of it. Otherwise, it gets difficult to maintain over a long period of time. So here's like the low-hanging fruit stuff that you can go get some quick wins with. Start with things that are high waste, low risk changes, right? Over requested CPU is perfect for this, especially on stateless services. Idle namespaces, orphaned storage, load balancers. I guarantee that you've probably stood up and then torn down a bunch of clusters, each that gives you the long-lasting gift of a forever load balancer that is going to cost you money unless you go and manually like kick that thing out, right? Turn it off. So those might sound like paper cuts, but you get 1,000 of them and it's going to be a bad time. They're going to cost you a lot of money. Those are some real easy, quick wins. Then move on to maybe more strategic changes that maybe require that you work with design, work with QA. Things like changing node types across groups, auto-scaling strategies where you want to be able to, move and optimize workloads, consolidation of clusters, bin packing. There's a lot of things, new policies around what types of storage and how much storage to use. Those are all pretty strategic things. You should work with a group of people to arrive at something that makes everybody comfortable and has a good chance of persisting for more than a few months as policy or guardrail, but then implement those changes that everybody agrees to, the things that really make sense. That's going to add up to a lot more savings. And then finally, kind of deprioritize low impact or short-lived workloads. Put them on inexpensive resources if it's possible. If the spend is really tiny, if the service is super short-lived, it shouldn't be the thing at the top of your priority list to go and point smart, skilled resources at that don't grow on trees. So pick your battles as kind of like the third point there. We can move to the next. Warwick, over to you.
Thank you, Joe. My nightmares tonight will be filled with forever load balancers. I'm now fearing going to sleep. Thank you very, very much. Just a brief chat now about how Kubecost as a product connects all these dots we've talked about. What you see here is a very brief overview of what a Kubecost structure looks like from a deployment perspective. This assumes Prometheus and a few other bits and pieces. But what you're seeing here really is how Kubecost is implementing everything we've talked about so far. We got Kubecost pulling in cloud billing data, Kubernetes metrics, and it puts this in a single cost model for clusters, namespaces, and workloads. So single pane of glass, for everything you're looking for around Kubernetes context, as well as a unified view for everything you need to action. It runs as self-hosted agent-based deployment. So it sits inside your Kubernetes environment, and it also works across all the major vendors, EKS, AKS, GKE, OpenShift, on-prem, you name it, wherever your Kubernetes deployment is, we can be there to help you work that through. Now, the cost model itself is extensible, so you can use provider bills or custom price sheets and still allocate shared platform costs back to teams. Really handy, really useful, and great visibility. Can we grab the next slide, please? Now, what you're looking to do here is view the views that surface what matters. turning your case costs into ownership, efficiency, and trends. Allocation and ownership in this case, aggregate data from Kubernetes primitives, from labels, etc. Obviously, it allocates all of that for you. The efficiency and waste, self-explanatory, views efficiency metrics and surface optimizations through savings insights. So really helpful, great interface there for that as well. And trends and anomalies, track cost efficiency over time, flag those anomalies, and forecast spend, all in a UI that's extremely modern, very, very, very easy to present and consume at all levels of the business. Now, back to you, Joe.
Thanks much. Let's wrap this up with some key takeaways. Does this sound too easy? I hope not. It's not easy, right? Get some data, figure out who owns the stuff that costs money, share that back with them, and do some optimization. It sounds like a easy mix ingredients, put in microwave, press button kind of a thing, but there's a lot of dense work there. Baby steps, start with easy stuff, move on. The things that I think are main takeaways here are Kubernetes cost management is hard, it's complicated, it's super dynamic, it's shared, it's transient. Getting just like the top level data for what Kubernetes is costing you is a sure path to having your Kubernetes costs go up and up and up every single month for seemingly no reason. So get a hold of it at a level more granular than just like cluster and node level. And that'll set you on the right path if you're just looking to take a first step. You're going to have to join your non-Kubernetes out of cluster cloud costs up with your Kubernetes usage metrics and ultimately their costs to see where money's actually going. This is like a takes two to tango thing, right? Kubernetes in a vacuum by itself doesn't work. It needs lots of cloud services, lots of resources. If you don't join those two things up, you're always just going to be seeing one half of the story, but not the complete picture. FinOps is a team sport, and it's going to take a lot of people working together to get this right, but visibility at those low levels, at the granular levels of workloads, namespaces, and teams is going to help people in finance understand, number one, what the heck is Kubernetes and how do I pronounce it? Number two, how to deal with these vague and sometimes misleading costs that come from it that get finance people asking questions like, do we really need this EKS thing? Do we really need that load balancer? Is this egress stuff important, right? It's going to help them understand at application levels, at department levels, at team levels, at business unit levels, where costs are, why they are, what they are, and work together to help you become more effective, cost effective. And the next is use efficiency to balance savings with performance and reliability. Like efficiency is a great litmus test for whether there is an opportunity to do some cost optimization without completely blowing up your app or your service. So lean on efficiency signals to understand the overall like financial and cost effectiveness health of any given project, initiative, service, etc. Start with the most important stuff first. High waste, low risk fixes. Those are the low hanging fruit things. Wait before you get into the really tricky, complex Zoot kind of auto remediation, auto scaling, right sizing stuff like in prod environments. Go after the easy stuff. You'll be shocked that probably 30 to 50% of your entire savings potential is going to be found like right in front of your eyes in things like idle, orphaned, and over-provisioned things. And last is we can help with a lot of this, and it doesn't have to cost you $1. Trying to do this all in spreadsheets, build your own Grafana dashboards, that way pain and misery lies sometimes, like after the fun part is over. So use OpenShift. It's our free open source project that we built and gave to the CNCF years ago. it has some great tools that make this much more of an easy button. Use the free version of Kubecost. It has even more features and capabilities than OpenCost, and is a great first place to start if you're just getting going. If you have needs that aren't met by those two solutions, reach out and talk to us about Kubecost Enterprise. We'd love to help you understand how it might help. And with that, I think we're going over to some resources. Dee, take it away.
All right, thanks both. So here's some resources we wanted to share with you where you can kind of just dig in to learn more about everything we discussed today. If you download that PDF version of the deck on your console, you can actually click on all these links. So we have a slew of Kubernetes guides on our website. You'll find I think we have probably 15 or so different Kubernetes guides there, but I put kind of the most basic ones that relate to this topic here. So we have one about best practices. We also have one about monitoring and simply cost optimization. But I think labels are going to be really key here, because you can't really do all the things we discussed if you don't have a good labeling strategy in place. So those guides will give you everything you need to kind of set the groundwork to where you can actually get to a point where you can begin to monitor and measure these costs more effectively before making those optimizations. We also included a link to our Kubecost install page. So like Joe said, it's free. You can install it in about 5 minutes and start seeing your costs right away. So that's a great place to start, even if you don't want to, dip your toe into the enterprise area yet. You can get all the same features with Kubecost Free as we have in enterprise. The only real feature gate between the two is data retention and advanced GPU monitoring. But for just kind of the basic stuff, it will have everything you need to really start playing around and see how it works. We also included a link to our Slack community. So this is a Slack that we have with a couple thousand users. So it's a great place to go for support, but also ask questions if you have something that you're tinkering with and want to connect with maybe one of our SEs or someone on the engineering team directly to get more insights into something that you're working on. And then we also included a link to our webinar series. So we've been hosting these for about 3 years now. So there are quite a lot of on-demand versions there. But you can also find videos of all of them on our YouTube channel. And like I said at the top of the hour, we will send a recording out of this session to you today. So I'll probably be sending that via email, probably like next Monday or so. So be on the lookout for that. But then you'll also be able to find it on our website as well as our YouTube channel. So now we're going to save a little bit of time for Q&A. We got a couple of pre-submitted questions, so we'll start there. But if you all have any questions, feel free to drop them in the Q&A feature on your chat there, and we'll definitely cover any that come through. But starting off, we got a question from someone that was, what is the best way to create a dashboard showing total cost of ownership by EKS applications in an AWS account?
I think I mentioned earlier that you can do it in like the fun science project way, certainly, right? Chain up like Prometheus and Grafana to your the APIs for AWS billing. It'll probably get you like the view that you're wanting. I think you could also just, if you've got some good labeling and tagging hygiene, you can just do some simple filtering as well. I would certainly recommend like using a tool like OpenCost or Kubecost Free. I think that's going to give you like right out of the box, as soon as we ingest data, effectively exactly what you're looking for in that. So it's a couple different ways. Mark, do you have any other ideas or suggestions on
just the labels.
Easy ways to get that?
Yeah,
labels. Yeah.
Labels there within either OpenCost or Kubecost Free. I think that's really the best way to do it. The science project way is certainly viable, but depending on your resources, etc., I'd certainly go to labels part.
Yeah, be careful. You don't want your company to fall in love with your science projects, because then you have to maintain them forever.
Yeah. We call it proof of production.
Right. Proof of production, indeed.
Awesome, thanks. And the second pre-submitted question we had here was, someone was asking about the roadmap plans for Kubecost and Cloudability, because as I'm sure you all know, Kubecost was acquired by IBM last year, and we are are now within the Apptio org. So we're all a part of the FinOps suite. So what does that mean? What's going to be happening with all the products to kind of create that synergy between everything?
Yeah, I can kind of take that from a product, and a strategy standpoint a little bit, and maybe work has some input on like engineering work that's happening as well. But long story short, we were acquired about a year ago. Cloudability, who is very, very strong and the leader by a large margin on FinOps for cloud costs, has come together now with, Kubecost, arguably the leader in FinOps and cost management for Kubernetes costs. It seems like a peanut butter and jelly, dream come true. And it really is. We are working to integrate these two solutions. We've announced integrations that are either GA today or are in either a private or public preview for an integration with Turbonomic, where you can get the optimization actions to save additional cost inside of the Kubecost UI. Integrations with Instana, where you're able to see the cost implications of things like deployments, patches, infrastructure changes. All really cool. We also have a product that we made an announcement for about a week ago at TBM conference in Miami, which is our intention to build and release a product called Cloudability Advanced Containers. This is going to be a Kubecost powered add-on for Cloudability, delivered as an optional SaaS module. And this will bring a lot of the power of Kubecost into Cloudability, kind of creating a single workbench, a single source of truth for teams that span the whole stakeholder realm in FinOps, from finance and FinOps to DevOps and platform engineering, to all have like a common tool to share goals and share metrics and share data with. So that's very exciting. We anticipate that will be available in the market sometime between the end of this year and the beginning of next. With more information to come, look for an announcement on that.
Awesome.
That's what I want to just emphasize the engineering side's excitement around advanced containers as well. This is a great synergy across products for us in Kubecost engineering. And it really does, it's going to be very, very helpful for a lot of people out there to have that tool with that sort of ease on a SaaS platform. With noting, of course, that Kubecost engineering continues. This is just one part of the structure and strategy we have for the product, and we've got a lot of other big announcements coming up in the new year and right through 2026. It's a really exciting time to be involved in the FinOps space.
Indeed.
Awesome. Well, thank you to both Joe and Work for your time walking us through this today. Just to wrap it up here, I did want to flag to everyone that we will be hosting our last webinar of the year on December 18th, and that is going to be titled Getting Engineers to Care About Kubernetes Costs. And so the topic of that is really going to be kind of setting the groundwork for your crawl phase when it comes to the FinOps maturity model. So we're keeping it nice and light and easy to end the new year, because to end the year, because I know a lot of people are going to be quite busy. So please join us then if you'd like to learn more. And with that, we will go ahead and end here. So thank you, everyone. Appreciate you joining today, and we will see you later.